Hello! In Lesson 4-3, we looked at proving triangles congruent by showing 3 pairs of sides were congruent, corresponding sides, 3 pairs of corresponding angles were congruent. And a lot of you said to me, that's a long proof, Mrs. Klein. Lots of writing. Well, the good news is there's shortcuts for this now. We're still going to prove triangles are congruent for the rest of this chapter and a little bit more for the rest of the year, but I've got some great shortcuts for you. So lesson 4.4 through 4.6 is all about the shortcuts, and today we're going to look at 2 of them. We're going to look at our first triangle congruence theorem, which is simply the side, side, side triangle congruence theorem. That's why you see SSS. That stands for side, side, side triangle congruence. And what it says is that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. We don't need to show that the angles are congruent also. There's an exploration in GeoGebra. You can find your link on the Moodle to convince yourself of this. So here's what we know. If we have triangle ABC, we see AB is 4 centimeters, BC is 6 centimeters, and AC is 7 centimeters. And we look over here at triangle DFE. Well, D to F is also 4 centimeters. E to F is 7 centimeters. It corresponds to A to C. And DE is 6 centimeters. It corresponds to B to C. Now, you might see it like this. You might see it with tick marks, where instead of a measure, you get a tick mark here and here. And you know those are equal. You might see 2 tick marks here and 2 tick marks here. And you know those 2 sides are equal. And you might see 3 tick marks here, 3 tick marks here, and you know these corresponding sides are equal. So you might see tick marks, you might see measures. Either way, if you've got 3 pairs of corresponding congruent sides, you can say triangle ABC is congruent to triangle FBE. Now the thing that's important here is remember, be careful that your corresponding sides line up in your congruent statement. Remember, we looked at those statements last lesson and said, okay, then that means A corresponds with F, B corresponds with B, and C corresponds with E. So that still has to be true in your statement. So if I started with A and went to B, well, that's the short side, and then I went over to C, that would be 4 centimeters to the 6 centimeters. So I would look here and say, okay, then I'm going to have to go F to D and down this 6 centimeter side to E. So F, B, E. Now you can start anywhere. There's lots of ways to name these corresponding congruent parts, but you have to make sure that they're in the right order. If I wanted to put, maybe I wanted to say triangle and call this CBA. I could do that. But then I'd have to say, okay, C to B to A, up the 6 centimeter side and then over the 4. And I'd have to say up the 6 centimeter side and over the 4. So I'd have to call it E to D to F. So say triangle E to D to F. Both of these are valid congruent statements. You notice A lines up with F, A lines up with F. B lines up with D, B lines up with D. C lines up with E, C lines up with E. So it doesn't matter which order you put them in, as long as whatever order you put this in, the corresponding parts work the same way in that one. So how would we use this? Well, lots shorter proof. Let's take a look at this at a couple examples here. You'll get some examples, some homework problems. They'll say use side, side, side triangle congruent. Might get a picture like this. And it says, explain why these triangles are congruent. Well, the first thing you do is you just look at your tick marks. Okay, PQ has a tick mark. So does PS. So I can say PQ is congruent to side PS. And then I see there's 2 tick marks for QR and 2 for SR. So I can say QR is also congruent to SR. And my reasons, I'll just number this 1, is that's given information. Now my only problem is I need side, side, side triangle congruence, and that's only 2 of them. So I look at the third side of each of these triangles, and it's P to R. So I know I have to say PR is congruent to PR, and then the question is, why can I say that? Well, I'm sure a lot of you are thinking, Mrs. Klein, I know why you can say that. We're saying that because of the reflexive property of congruence. We know that any side is equal to itself. They both share the same side. You know PR is going to be the same length, whether it's on one triangle or the other. So anytime you're saying one statement, oh, I forgot to put my second symbol. Anytime you're saying one statement, one side is congruent to itself because it's shared by two triangles, you just call it by the reflection property of congruence. If I wanted to do, maybe I wanted to do this one. And I want to show why triangle MNP is congruent to MQP. Well, again, start with your given. Okay, I've got NP here, and I've got QP here, and I see they've each got a tick mark, so they're congruent. I have NM here, and I have segment QM here. They have two tick marks, so they're congruent. So once again, my reason is given. I have a figure, I have tick marks, they've got to be congruent. Now I need my third side. So where's the third side of each triangle? And I see it's this side that they're sharing. So once again, third side, but second statement. I can just say, well, PM must be congruent to itself, and that is by what property, folks? The reflexive property of congruence. So that's all you're doing. When you're doing an explanation, a two-column proof is fine. There's no need to get any more complicated than that, so that would be awesome. Now the next theorem we have is the side-angle-side congruence theorem. And that says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, the triangles are congruent. So you might see pictures like this. I've got triangle BAC. Notice that I've got this marked as the same in both these triangles. So I've got two sides and the angle in between them. It's got to be the angle in between the sides. Notice up here it says the angle is in between the two sides. And then over here I've got triangle DEF. We want to show those are congruent. Well, because we see a pair of sides, a pair of angles, and a pair of sides, we can conclude that they are. Again, be careful to line up those corresponding parts in your congruent statement. So, how does that look in a problem? Use side, angle, side, triangle congruent. We want to explain why triangle, and you might get something like this, and you know when I get something, I see a bunch of triangles here. I see 4 of them. You could be looking at a bigger one on each side. A lot of ways you can go with this. So if it says, give something like this, explain why KPN is congruent to triangle LPM, I would go KPN, and I would outline it. I would draw it on my paper, and I'd outline it in a color so that I knew exactly what triangle I was looking at. And then LPM, I can see that's this triangle over here. And you've got to just be really careful. You've got to educate your eye, do a little bit of drawing, maybe shade them in even, so that you can see what triangles you're looking at. Well, now that I see this, now that it's shaded in, well, now it's a lot easier. What do I know? I know K to P is congruent to P to L because they each have one tick mark, and I know N to P is congruent to P to M. And those are both statements I have from the figure, what was the tick mark, so I know those were given. Well, they said use side, angle, side. So now I look at the angle in between these two sides, and it's this one here. So why would this angle be congruent to this one? First off, I have to name them. It says use side, angle, side, so I know that's got to be the case. So I'm going to name those angles, and there's 4 angles right there, so I have to actually use 3 letters. So I'll go angle KPN. KPN is congruent to angle MPL. And then my question is why? Why do I know that? Well, I hope all of you can see that those are vertical angles. They share a vertex. They don't share any sides. So we can say they're congruent by the vertical angles theorem. And that explains why. So we know, and you can even write a conclusion if you like. Therefore, triangle KPN is congruent to triangle LPM. And why would you say that would be? Well, it would be the side angle side triangle congruent theorem. And you're welcome to just abbreviate it that way. So that explains, and when you put that final conclusion in there, you've written a nice proof. So as your thinking gets going, that's great. We'll look at one more here. If we look at this one, we want to use side angle side again. We want to explain why ABC is congruent to DBC. I'll start with what I'm given. I'm given AB is congruent to BD. That's a side. And I'm also given these angles. So angle ABC is congruent to angle DBC. So those are my two pieces of given information. So now I have to think, okay, it's a side I know, and then it's an angle. So I have to have the other side that would make that angle. So I think if I've got a side and an angle, I need this side here on both of these. So that's what I need. I need to show that BC is congruent to BC. Well, that's another easy one. We know from side, 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 hey, it's the same on both triangles, so you know what? It's just the reflexive property. Property of congruence. And then I can say, just to finish it off, triangle ABC, and it's easy to kind of go along your triangle and think short side, angle you know, long side. So short side, D to B to C. And why would that be? Side, angle, side, triangle congruence theorem. So this is how you're going to do your homework. I hope this really helped you out. And ask me questions if you need to. Thanks.